So I'm Yan Zhu. I am a security engineer at Yahoo by day and by other days, because I don't really work at night. I'm a technology fellow at the Electronic Frontier Foundation.
I'm Peter Eckersley. I lead the technology projects team at EFF.
Hi, I'm James Caston. I'm a technology fellow at the EFF and a PhD student at the University of Michigan.
Great. So who here is excited to encrypt the entire web? Oh, wait, actually, yeah. I like the energy. Okay, so what are some problems in the world today other than global warming, child hunger, and all that? Another problem, TLS is not ubiquitous, and it's 2015. For instance, last summer when I went to Quora, this was actually the last time I ever logged into Quora, I noticed their login page was just served over plain HTTP, which is already bad, but also opened up DevTools, and lo and behold, the passwords were actually being sent over clear text. This is pretty bad if you are a site with millions of daily active users, but actually in Quora's case, their purpose is kind of to spread misinformation about various topics, so maybe it's not bad if you have a man in the middle. I don't know. But there's also this little site called Google. I don't know if you've heard of it. Raise your hands if you have. So Google's been pretty good at SSL, but some pages, like this one, which is the landing page for Google Ads, still over HTTP by default. Now you might say, okay, that's fine. It's just like a static page. It's all public information, no user data. But a man in the middle, such as myself, can inject a button that says login and make it look really lifelike and googly and all that. And an unsuspecting user will click it, where I will redirect them to my phishing site, and they'll enter their credentials. So because they don't use ubiquitous HTTPS, this is still a problem. And that's why we can't have nice things yet. Second big problem of the world is that setting up TLS is still really tedious, even in 2015. Who here has done this process recently? Yeah, a lot of you. So you know how bad it is, right?
They still have one at least each.
What's that? Okay. For instance, if you want to do this on DreamHost, you go to their web wiki, and it's a 12-step process, and you're not in Alcoholics Anonymous yet. But it's still a 12-step process. Ridiculous. So I'm pretty experienced in doing this, but how long does it take a total newbie to set up SSL for the first time? Well, I made a little video with some of my coworkers from EFF. So I basically went around the office and I asked some people, can you set up TLS? And none of them had done it before. So hopefully this will work. Oh, hello, Parker.
Hi.
What are you doing today?
Just going to try to set up HTTPS on my website.
That sounds fun.
Yeah, maybe.
Can we film you for a DEFCON video?
That's okay, yes.
Great.
Okay. Okay. Wow, I didn't think that was going to be clickable. No kidding, it's 100% free. So, how do I do this? Free. Okay. Click the wizard. Start SSL control panel. Okay, I guess I'll open that in a new tab. Oh. Alright, well.
So their site was down that day. Well, I guess we're not going to do that today.
Okay. You can probably stop rolling.
That's a
wrap.
it. So then I went to someone else in the office. Now here we have Noah making sure he can get email at webmaster@catplanet.cat, which we'll need later to set up an SSL certificate. Except he forgot his password.
There won't be audio on this thing, right?
Probably not. All right, 3 minutes later. What's up, Noah?
don't know if my email works.
You don't know if your email works?
We started already? Is this the thing?
Yeah, we are totally filming this.
To put up for DEFCON?
Yeah.
Why?
So, because Noah has not figured out how to get mail, he is going to get coffee instead. And we're going to resume this video when he figures out what's going on with his email.
This is the website we need to get secure. Secure. Free. Let's do free. No kidding. Free. That's not clickable. That's not click this. Oh, express lane. I want express lane. All fields are required. Noah. Certs. Do I really have to give them my real home address? High grade? Medium grade. Let's go with high grade. It's probably better. How long does it take them to sign it? Congratulations. Okay, catplanet.com. No, catplanet.cat. Where is .cat on this list? Webmaster, catplanet.cat. Okay, taking a while. Taking a while. What does this mean? Generally free of charge. Handling fee. But where's my... Is it attached? Where's my certificate? Why do I have a random congratulation email? Where is it? Is it in my browser? So here I am, still waiting for the email with my certificate. I got a thank you email, which maybe points me to an account, maybe has my certificate in a link, but I have a proxy error from their website when I try to go to it. Yeah, after an hour and multiple tries, no certificate.
So I'm sorry that was such a sad video. I hope people have tissues and you're able to cope with this after some therapy. So the whole process of doing this took us several hours due to various mistakes we were making and all that. That's pretty unacceptable. Let me see if I can switch slides. All right, so let's assume that went perfectly and we got our certificate. Now we have our certificate and we want to set up SSL on our server. But SSL configuration is really confusing. So a few years ago, people were saying, oh, RC4 is fine, it's very efficient, it's fast. But now in 2015, experts like Nick from Cloudflare are saying, we need to kill RC4. Another example, Chrome is sunsetting SHA-1 because it's not secure, and sooner or later, if your site uses SHA-1 hashes in the certificate chain, you'll be displayed as insecure in Chrome and Firefox. So I think we should make a movie called The SHA-256 Redemption. It's about a man who is mistakenly accused of using SHA-1 on his website and gets fired from his sysadmin job and meets Morgan Freeman and spends all this time convincing people he actually used SHA-256 in theaters next fall. Other examples, so like even later in the fall, people said, we should disable SSL v3 now. Okay, so now SSL v3 is off the table. And then there's logjam, and logjam means you have to generate your own Diffie-Hellman group. And you know, the point is, if you're not paying attention to this stuff, you can fall behind, and your SSL configuration will be horribly insecure. And if you use a config audit tool like SSL Labs, it'll just give you an F, as cryptanalysis attacks get better and so forth. Notice that let'sencrypt.org is getting an A+. It's actually one of the best sites that SSL Labs has seen recently by their metrics. What's that? Okay. Yeah, sorry, I did that a few days ago. Anyway, but we use the latest recommended ciphers from Ivan Ristik's book, which I'll put a plug-in for right here. Right. But the problem is most people don't have the capacity to keep track of when they should be changing their SSL configurations. And so we end up with kind of a broken encryption on the internet. Problem 4, mixed content blocking. So this is keeping a lot of people from transitioning to full HTTPS. Mixed content blocking is when your site is over SSL, but you're loading all these resources from HTTP. So the browser says, okay, we need to keep the user at the HTTPS secure level. So we're going to block HTTP resources that you try to load. And so your site's just broken if you load scripts from HTTP. In the case of Lenovo, which I checked out a few nights ago, it's available over HTTPS, but they can't load their fonts yet over HTTPS. So by default, you're going to use HTTP. So who here uses HTTPS everywhere? Wow, awesome. Peter and I work on maintaining that browser extension. So if you use HTTPS everywhere in Chrome, you can go to a website and actually see what resources could potentially be written in HTTPS. So this is a pretty useful developer tool if you're trying to convert your site from insecure to secure and you have a lot of third parties and you don't know which of them support SSL. So open up DevTools and there's like a tab you can play with where it helps you rewrite stuff. And W3C is also going to help you all out. There's a new header in CSP called upgrade insecure requests. So when a browser sees the header, it's going to say, oh, this site wants us to upgrade all sub-resources and links to HTTPS, even though they're written as HTTP. So it will try the HTTPS request, and if that fails, it just gets blocked. But it won't do the insecure network request. So that's also useful. And I think the final problem is that there's just too many certificate authorities. It's a lot. So Peter and some of his colleagues made this very complicated, scary-looking graph a few years ago. Peter, can you tell me what it means?
Yeah, so this is a map. It's not the whole map. It's actually a little portion zoomed in of the whole map that we presented at DEFCON in 2010 from the SSL Observatory project. And when we set out to do that project, we thought that there would be about 66 certificate authorities in Firefox and maybe 150 in IE. But then when we scanned the internet, we realized that they'd all been signing and delegating to other certificate authorities that weren't in the official trust root, but which would actually be trusted by browsers. And we concluded there were thousands of CAs operated by at least many hundreds of organizations, and a compromise at any one of these CAs could basically compromise any domain on the web. So kind of terrifying.
That's really scary. I'm not going to be able to sleep. And in fact, this year, Google found misissued certificates from Chinese certificate authority. So this is not just a theoretical attack. We've actually detected this in the wild. So Peter, this sounds pretty bleak. How are we gonna make a world that we want to live in the future?
So our solution to the problem of there being far too many certificate authorities and to all of these other problems is actually to start another certificate authority. But really, in more detail, as I'm going to explain in the next few minutes, we need a detailed vision both for security, for a way that we can get every website the cert it needs, and not certs it's not supposed to have. So a solution for security, and also a solution for usability, so that humans who are just web developers and don't want to go all the way down the insane rabbit hole of all the strangely named SSL vulnerabilities and the animals they're named after and things, they don't need to know about that stuff. So the biggest question we need to answer for this project is, if we're going to issue certificates, how do we decide whether to do so? And you can think of this as being a little bit like that scene from the Holy Grail, where someone shows up and says, "I want a certificate," and you say, "Bring me a shrubbery." And then you go off on your quest, or you have your software go off on a quest and come back with the shrubbery, and then you're like, "Oh, it's nice, but I think I'd like a different other shrubbery as well." And so this dialogue, hopefully it's not quite so comical, it happens in this new protocol we've got called the Acme protocol. RCA will speak as a server, and we'll have a client as well, but you can write your own clients if you want. And then the shrubberies are called challenges. It's a particular task that the client needs to perform to prove that it deserves a particular certificate. And there's this fundamental issue that you have to deal with these challenges, which is you're bootstrapping from non-cryptographic authentication somehow up to crypto. And how do you know what key to use when you didn't start with keys? The traditional typical answer for at least bulk issuing certificate authorities, the ones that are comparatively cheap and will not charge you $1,000 or whatever, is to just send an email to an address at that domain name, maybe admin or root or webmaster or something. Just send off that email, totally insecure. If a link in the email gets clicked, then whoever asked for it to happen gets the cert. A smaller number of CAs will do this thing where they go and inspect an HTTP URL and see that you put up a nonce that they gave you at that URL. So we are going to do some variant of this type of domain validation. The types we're going to support at launch. There's a new DV protocol we've invented called DVSNI. That works at the TLS layer, and the aim is to prove not just that you're a user on the destination machine who happened to register the name admin, but that you actually have administrative control over the web server. And you can configure it to answer for synthetic fake virtual hosts that we've asked you to answer for. We do that in the TLS handshake. We ask for that name using the SNI header if you know it, and then we inspect the results and make sure that you're able to customize those. We also support simple HTTP, which has a little bit less of that security in it, but it is also going to be necessary for some people who are behind proxies or CDNs. And in the wild, we'll get certain numbers of attacks against these things that succeed, and we'll monitor the statistics and see how that's going, whether we can keep doing both. But probably down the pipeline, people are asking us for extra things. One that we get a lot of requests for is DNS-based validation, especially for large deployments. Just have the DNS name post a nonce in a special record. And another one we may do is an upgrade of the DVSNI protocol to do a whole lot of domains in a single handshake. So you don't have to do, if you're virtual hosting 1,000 domains, you can just do one fancy set of challenges and not 1,000 challenges over and over again. And we might do that on a different port, one extra port in addition to 443 for people who want to keep their firewall 443 going the way it is, and then point a special port somewhere else. We'll have to do a lot of auditing on that port before we pick which one we're going to use. Probably that'll involve internet-wide scans and a call for comment. But fundamentally, all of this domain validation stuff is a bit terrifying. Basically, you can imagine the internet as being like a very dark hallway, and you're flinging some packets down that hallway. You can't see where they go, and something comes back and says, yeah, I'm really this domain. And it could have been eaten by monsters or modified. You have no way of knowing in general. And so you will get attacks. If people compromise routers, compromise DNS servers, they can defeat these methods. Not very reassuring. We can do slightly better than that. So we can do multi-path DV, where we use servers in multiple data centers in multiple parts of the world to make several versions of the validation requests or several versions of the DNS query. This doesn't completely protect you. A very powerful adversary might compromise each of those places, or someone might just compromise a router near the victim. So there are multiple dark paths through the internet, but they all wind up in the same room and being eaten by the same monster. So this probably isn't good enough for us to build the whole internet security infrastructure on top of yet. But we can do better than that, actually. So what we need to do is ensure that this leap of faith down the dark hallway really only happens once. How do we do that? We were talking before about the SSL Observatory project. We spoke at DEFCON 5 years ago about this. Since then, there have been a number of these cert gathering projects. The centralized observatory we talked about. We have a decentralized set of about 1 million Firefox clients who opted into sending us certificates. There's the certificate transparency databases run by Google and others, and the ZMAP project that James and his colleagues at the University of Michigan have done. And these build giant databases of all the public certificates in existence. And so we know the entire SSL-verse, at least the public portion of it, at any given moment. And that lets us do this thing where when someone comes through the door and asks for a domain name, like a bank in New Zealand we've never heard of, or a corporate webmail system somewhere, we can say, look in the database and say, oh, there is already a valid certificate for this domain name that you're asking for. We're not going to just do non-crypto domain validation. We're actually going to ask you to prove possession of the private key in the existing valid certificate. So that way, you can only get a certificate from us if you've already got a cert by signing something or decrypting something with the key in that cert you have. This is going to be a little bit less usable. It may mean that you have to go chasing around to figure out where your existing key is for your cert. In the worst case, if you've lost it, you might have to go to another certificate authority and buy a cert. But we will ensure that we never robo-issue to a bank or a valuable webmail site or anything that has a certificate right now, just because a router got compromised. So you might notice if you've heard of tofu authentication, this mechanism lets us get tofu. Tofu is trust on first use. You're probably most familiar with it from SSH. It's the model where if whatever trust you establish on your first insecure connection, if anything changes, the person at the other end changes, you're going to notice and be protected against it. So we think that's pretty nice. Now the next problem we're going to have to deal with is basically the horrible complexity of TLS configuration. As Jan was showing, there are poodles and log jams and heartbleeds and all these things that can get you. And what we want to have is basically a client that runs on your server, an agent that runs on your server and magically figures out the right way of doing things for you. At least if you want that. And so what this does is it takes the current situation where every webmaster, every web developer out in the world is like a giant crowd of these millions of people, and we're sitting up here as a security community kind of yelling at them saying, here, understand this incredibly complicated corpus of knowledge. All of you need to understand this incredibly complicated body of knowledge to customize each one of your sites correctly. And it would be way saner to have a world where we can have a small team of people, maybe just the people in this room, the people who want to contribute on GitHub to the project, focus in on how we actually do TLS deployment correctly, do it once correctly, and then give everyone else a tool that just sorts out the details for them. So that's the aim with the fancier client that we're supporting here. And the aim, the plan for when someone gets this and installs it in 6 months or a year's time is that it'll support tweaking their existing server, Apache, Nginx, or anything else. We have a little API that you can use to support new server software, to pass the challenges, and then install the resulting certificate, or certificates if you need lots of them, and then tweak all of the security parameters and options so that they have good values, either maximizing security or maximizing security subject to the constraints of compatibility with old clients, depending on which one you want. And automating tasks like renewal and response to security incidents that right now cause massive problems for HTTPS deployments. So some of you probably are a little terrified if I'm saying automate security tasks. So let me talk about what we mean by doing that. Because there's a spectrum. There's easy stuff, like tuning the cipher suites on our server. We go and look up some lists of recommended cipher suites and debate them for a while and then pick a good value. We turn on OCSP stapling so that everyone can actually tell whether the certificates have been revoked or not. We turn on the upgrade insecure new header that the W3C just specified because it's basically a no-brainer to turn that on. More tricky is redirecting from HTTP to HTTPS. Because of mixed content blocking, even with upgrade insecure, sometimes this can cause breakage. we can maybe do a fancier version where we look to see if you've got a client that's modern enough to know about the upgrade and secure mechanism and do a differential upgrade for the modern clients and leave the old ones on HTTP. Similarly, auto renewal and rekeying, we've got these implemented actually largely, but they're a little tricky. There are a lot of corner cases. What happens if you fail to renew a domain and so now you have or something went wrong with one of your domains, so you have an old cert that's for more names, but it's about to expire, and a new cert for fewer names, and so at some point you have to transition. You want to try and tell the admin, hey, like, please pay attention to me. I'm a program on your server. I'm trying to juggle your certs. There's an issue, but the admin's not reading their email. So we want to get these corner cases right, but we think we can do this pretty well. And then the hard stuff is full rewrites for everyone and turning on HSTS. You should all know about the HSTS header. If you don't set it, your site is totally insecure, but it's also the kind of secret sauce that can break sites if it's not done correctly. So we'll need to be very hand-holdy and give the admin good tools and advice to turn these options on when they're ready and not beforehand. And the hardest stuff, which we may build, but it won't be there straight away necessarily, is HPKP pinning, which lets you lock out all the other certificate authorities, but can really break sites easily, and full mixed content auditing automatically somewhere via a proxy in the server or via CSP report back. This stuff is theoretically possible, but it's a big engineering task that's down the road. But fundamentally, CAs are terrifying things because they control the security of the whole web, and we're trying to build a giant automated certificate authority. It's a giant crazy machine, and we have to be a little bit afraid of the thing we're building. And so how do we design for safety as we build this giant robot authentication machine? So one part of the answer is defense in depth, and I think the things I've been describing to you are in fact forms of that, trying to ensure that we have multiple tests in place and we don't fail because one of them was attacked. But also we need to plan to detect and survive really serious kinds of compromise events because we're going to have a giant target painted on us. So protecting against ourselves, basically. And we have a few cards up our sleeve for this. One is to be incredibly, and all of them amount to being essentially incredibly transparent. We're going to publish the logs of the transactions that we have when people come and ask us for a certificate. As a public server asking for a public certificate, we believe that that's actually a totally open public event. So we'll list the logs, what IP addresses are asking for what certs, and what happened when we tried to verify that. We'll publish a full verifiable history of every certificate we issue. So you can go and look at the logs, see all of them, see that they have an incrementing portion in their serial numbers, they're all signed. You can collect the set of Let's Encrypt certificates really easily if you want. And we'll also push that data into the certificate transparency logs. So people can validate that every cert they're seeing, if they want to, is there. Now, we'll also help you with HPKP at some point. If you're in power user mode and you're really brave and crazy to lock out the other 1,000 CAs, you probably will still need to keep us and a couple of your choice as backup options. You should never just pin to one CA, because if you break that pin, your site will become unreachable for months. And it's happened to people. And then we also need a plan. What happens if we do get compromised? What happens if an employee of our organizations is working for someone else? What happens if there's ODE in our systems? What happens if we just screwed up and there was a bug in our code that we should have spotted, but one of our systems gets compromised? And we're planning to, and what happens if our keys get factorized? We keep seeing crypto attacks that are very powerful. What happens if those affect us? And the plan there is to have some mechanisms that allow really fast server-initiated responses to security incidents. So if a Heartbleed event happens, we should be able to put up a flag on 1 million certs and get them within 24 hours all rekeyed and reissued. At least if the clients are polling us and saying, hey, do you have an emergency for us to respond to, we can tell them, and that can happen before the sysadmin gets out of bed. If they want their site working that way. And then we can also do recertification if one of our intermediate CAs were to be compromised. We're not too big to fail. We could actually switch it out for a different one, go to the cold storage, the bank vault, get out the key, make a new one, and then roll everyone onto the new cert really fast. So these are structural protections that we think help make this safer. So
institutional and kind of organizational details. This project began as a merger of an EFF and UMich project to do this and a Mozilla project, so it's now all of those organizations teaming up together. It's housed in its own nonprofit called the Internet Security Research Group, or ISRG. And it has major sponsors, EFF, Mozilla, Cisco, and Akamai, all putting a lot of resources in. Others really helping out IdenTrust, Automatic, and the Linux Foundation helping to do the administration for ISRG, and a couple more sponsors on the way. Roughly, the breakdown of which bits are being done by which teams, operations of the actual CA servers and so forth, ISRG and Mozilla, server code Mozilla and EFF, client code EFF and UMich, and everyone's been chipping in on the giant complicated policy and legal and bureaucratic tasks that happen here. And the current schedule we have, this is as of this week, we had a slight revision. So we're going to have our first cert issued during the week of the 7th of September. There'll be a public validity, so default browsers will trust these certs from sometime in mid-October roughly, and there'll be a beta program to start actually deploying them on a wider and wider set of sites. And then general availability for everyone will be the 16th of November. In the meantime, we have a lot of work to do. There's both the bureaucratic tasks of passing the crazy audits and producing the insane documents, and then the documents of your documentation about all of your backup plans for everything. That's one of the giant tasks that makes starting a certificate authority expensive and time-consuming. So we just have a couple of people working through this. They're incredibly valiant and tenacious in getting those audits passed, and then code. And if you guys are interested, our code for both the server and client pieces are on GitHub, and the spec, you can come and hack on it, help us break it, help us fix it, help us implement some of the cool features that we talked about but haven't got yet, and help us ultimately encrypt the entire web. But I'm not going to leave it there. I'm going to hand over to James to give a demo of the way the client works and some of the stuff we have running right now.
All right, so I'm James. Hopefully we can do a live demo here and nothing will go wrong. Pray to the demo gods.
Nothing ever does.
There we go.
If you can increase your font size.
Can people see that? Or bigger? I think that's about as big as we can go.
All right. So right now we're using virtual environments, but hopefully we'll get into. Sorry, a little bit tall here. Hopefully we will get into package managers here. Right now when you download the code off of GitHub, it gives you instructions to set up a virtual environment, and our clients run in Python right now. But let's go through an example here. So pretend we have an enthusiast, who owns encryptionexample.com. He likes to teach people about crypto. Unfortunately, he can't set it up himself. And he's also interested in making money. So he registered the site tlstrust.us. It has everything you need to be secure. It has all the logos, and it has the lock icon up there. But it doesn't actually run over TLS, which is unfortunate. It looks secure to me, but you know how that goes. So luckily Let's Encrypt came out, and he can he has an Apache, used to Emacs. He has an Apache server that
You control that?
yeah, sorry, I'm not used to Macs.
This is James's first time using OS X. So
Yeah, sorry.
Let's give him that.
All right, so when you run the client, it asks you to go through an end user agreement right now because it's a preview release. But basically, the client will actually go through your server configuration and figure out what names you're hosting. So it goes, search through the config files. You can select which names you'd like to use. The first example, we'll just do encryptionexample.com. And it actually will go through and solve the challenges for you. So it's kind of listing what it does here.
Those are shrubberies going past.
Right, all the shrubberies. UI can use a little tune-up here, but in that time frame, we've actually completely solved the challenges and set up TLS on the server.
That was 20 seconds rather than 3 hours. This is still self-signed
Right.
for the demo.
Yeah, there we go. Yeah, so we have an HTTPS server. Now, mind you, that it's self-signed because we don't actually have the CA up and running yet. Yeah, if you trust the Happy Hacker root, which I don't advise because the private key is public, you know, we can. You too can get that green bar up there right now. The logo, Let's Encrypt logo, or are you talking about extended validation certificates? Oh, okay. So we can also, you know, it's probably advised that for the TLS trust.us, we're always going to want to run over HTTPS. So we can run, and you can actually specify everything on the command line and not use any prompts at all. But once again, it will quickly set up the server, solve the challenges, and it also will create a redirect from the original HTTP host to the new host. So that's all great.
And so we're going to add some nice little ncurses UI in there that asks you, do you want easy mode or secure mode or custom mode, and it'll try to figure out which of the dozen or 24 security features like redirects, HSTS, OCSP stapling, etc. you want configured for you.
Yeah, so now you're safe. TLS trust.us works. Now, some people obviously don't want us to actually touch their configurations, which, you know, makes sense. And if you do want to simply remove everything, you know, or we mess up your configuration, which we won't, hopefully, you can roll back everything that I just did. There are 3 checkpoints. Roll back everything, and now HTTPS is no longer enabled on anything. It goes back to the original state as if we hadn't touched anything. Finally, you know, what?
Does it revoke the certificate?
Not yet, right now. It doesn't revoke the certificate. We will have another management system that you can manually revoke all the certificates and see. I was trying to get that ready for the demo, but I couldn't quite code fast enough, especially with the spotty internet. Finally, you know, if we don't support your server right now, or you simply want to use another technique, you can specify we have a manual authenticator, which will not require root, so it simply gives you the file to post to your server. And a standalone, which you just click and it will automatically get your cert and drop it in the current working directory.
Right, that one listens on port 443, so you have to turn off your existing web server if you have one.
Yep. But yeah, that's it.
Do we have time for questions? 10 minutes for questions. Awesome, let's go. I think there's a mic, so you should go up and ask questions in the mic.
Am I on? Given how hard it is to get a cert, how hard was it to become a certificate authority and getting accepted by the browser vendors?
So, we didn't talk about this. Okay, how many people here think that in order to become a certificate authority, you need to be accepted by the browser vendors. Can I see hands? You need to get into the thing? I'm saying like, so many of you may have realized that you don't need to be accepted by the browser vendors at all. Actually, all you need to do is get one existing certificate authority to promise by contract to cross-sign you, and then you're in all of the browsers instantly, if that existing CA was. So the crucial thing for us was getting an agreement with a certificate authority saying, yes, if you pass some audits, we will cross-sign you. And then once we had that, we could talk publicly about the fact we were going to do this, because we had a reliable path to being a browser-trusted CA. Now, passing the audits is a lot of work. There's an incredible amount of bureaucracy there, documents that are hundreds of pages long with requirements that began as sensible things that we would all think, oh yeah, you should probably have a backup plan and then an emergency plan. You should have a way of vetting your personnel and a way of revoking their credentials. And you write all of those things down. It becomes a really long list. And then you write down another entry saying, okay, now document your answers to all of the previous questions and now pass an audit where you get asked where the documentation for the documentation is. And so it costs a fair bit of money and takes a lot of time to do that stuff. And we're close to having all of it done. We're going to have a cross-sign from a CA called IdenTrust.
So one of your tenets is to make it very easy to get these certs out there, which is totally awesome, but it's still to a technical crowd. You were at the command line. The demo was awesome, by the way. Is there plans to get involved with something like cPanel or the VPS hosting environments where end users who are not so savvy can easily get certs?
Yeah, absolutely. I mean, we want to have those tools available. The Let's Encrypt client, the fancy Python one, can be used by those hosting environments, or they can code up their own client. I think there'll be a trade-off for different people. Some will do their own coding, and some will just deploy our code.
So API?
Yes. There are two APIs, actually. The Acme spec is itself an API that you can code to. It's a protocol. It's open. And then there's another API for our client, which is basically you have a new server. So you might want to write, for instance, a postfix or an XIM or an XMPP server module or an IMAP server module to obtain or deploy certificates for all those different things. And we have a simple API against our Python client that helps it understand new types of servers.
So obviously with certificates, you have to think about revocation lists, and something as large as encrypting the entire internet, you're going to have a pretty big revocation list. And I guess a popular strategy currently is purging it every now and then, but that can cause security issues for certificates that were actually revoked because of compromise if they get pushed off the CRL with things like ZD signatures. So what is your plan for dealing with that? Are you just...
So we're going to do OCSP as well. I'm not actually, I can't remember our latest plan for CRLs. Basically the main reason for doing CRLs is to make sure that Google and other people who bake in revoked certificate lists are going to have a fresh way of knowing which of our certs are going to be valid. We're also going to be launching with a 3-month validity window. So we're going to have a little bit less risk from unrevoked certificates structurally than most CAs. And in the long run, perhaps we could aim to one day have an OCSP must staple kind of environment, but although I think that's a little bit more speculative. And there's a lot of missing technical pieces and unsolved technical questions because revocation on the web right now is broken.
Thanks.
So on the server side, when you're actually updating configs on behalf of users, like for Nginx or Apache, do you have any plans on integrating with the configuration management tools that might also be vying for updating those, like Puppet and Chef and all of those things?
So we want to be...
Yeah, we'd like to write an installer for Puppet and Chef. I'm well aware that that is a major need there. We just haven't gotten around to it yet, but it should be possible. And if people want to write their own clients, that would be great too.
Awesome. Actually, these are exactly the kinds of tasks that make a lot of sense for volunteers because they're very separable. We have a fairly clean API for extending client functionality. And so if you want to make one of those things happen, come and find us on GitHub.
Cool. Yeah, no, I work for Puppet, so I would love to see there be like a good integration there. So I will totally check that out. Thanks.
Yep.
Hi. As we know, a lot of ad sites or web content are paid for through ad sites, and as you push to encrypt all these sites and everybody goes encrypted, you deflect the ability to inject ads dynamically. How do you think that'll impact content generation on the web, and do you think it'll push to a more paid-for style?
It's funny because we also just launched Privacy Badger, and you could ask us a more pointed version of that question about Privacy Badger. The answer is I don't think there's any technical reason why ad tech companies can't all just switch to HTTPS. There's nothing that you can do over HTTP there that you really can't do over HTTPS. In my conversations with those companies, we just get referrers. Yeah, but I mean, much to my sadness, actually, you can get referrers. Either you can post them, which is what ad companies typically do, or if it's HTTPS to HTTPS, they're largely still there. It's complicated, but mostly they get blocked because it's an HTTP destination and HTTPS source. So I think that there just has been this attitude amongst some ad companies saying, why should we do this? We don't see a reason. And others, I mean, I've been in a room full of ad tech people yelling at each other where some of them are saying, you need to do this. Why are you not doing it? And others just saying, we don't see a reason. And I think the answer will be everyone just ends up doing it.
Hi, y'all have a lot of plans that seem pretty lofty and very large goals. You said you have 2 APIs publicly available. Do you have any other APIs planned, and if so, when and what will they do?
No other APIs planned in the for this project in the short term. And one of those 2 APIs is very small. So the big one is the Acme protocol, which is like, it's going through the IETF. The Mozilla team is largely shepherding it through there. That's going to be a big, new web protocol to do this kind of stuff. The other API is much smaller. It's for our Python client, and it's basically a way that you can write some Python code for your particular server that slots in neatly. You can think of that as being much more a plug-in infrastructure for the client.
Thank you very much.
I was one of the guys that said that not every site should have SSL. I think specifically I don't want to see phishing sites with SSL. You've talked about your plans for avoiding direct collision. So site.com, you're not going to reissue to a different actor. What's your plan if I go and get site-secure.com, sort of very low-tech, homoglyphic type attack? How are you going to deal with that?
I think that this is actually still an open question. We are talking a lot internally about 2 different plans, or 2 different even types of plans. So I think from a first principles basis, we agree that we need protections against phishing. The internet needs to not phish people. But there's also a question about whether the X509 layer is going to continue to be the best layer to do this, because it's traditionally been the layer at which this occurs because of the lock icon and the sort of fetishization of the lock icon, which made sense when that was a mark of a trustworthy e-commerce site versus a random site.
It's not trust, it's identity. TLS gives you 2 promises. It gives you identity and transport security. If you're saying X509 not the identity platform, what is?
Finish. So if we were going to do it outside of X509, the 2 places it could go would be into the domain name system itself, or it could go into the client. So that there's a richer API, because the client has, and it already exists in clients with safe browsing. From Google and used by other browsers. So one option for us is to take our data sets, do our homoglyph detection, do all of our maximum protection against phishing, and just pass that data set over to safe browsing or over to the DNS registrars and say, we have a flag going up about this domain, here's all the evidence. You make a decision about how to show the user the right UI around warning them off being phished here. The other option is we do that ourselves inside our own infrastructure, but there are some costs that come to doing that. And I'll tell you a couple of them. One is when we deploy HSTS, for instance, an auto renewal for people, and then their site gets onto a watch list because they host 10,000 software downloads, and 3 of them turn out to be malware, and so they get put on a safe browsing list. If we, for instance, were to go around and respond to that by revoking their cert, and they've deployed HSTS and we've helped them, we cause an unrepairable outage at their site. And so it just seems that it's dangerous to do this kind of detection with false positive rates inside kind of a basic protocol layer that affects communication. So, we haven't got a choice about this, but these are the factors that we're weighing up. There are also people who just say politically, I run that site with 1,000 downloads and Google blocks me sometimes. I don't want to be denied a cert and the ability to communicate with people because I have this blacklisting problem. And so I think there are arguments on both sides there.
I think you're also looking at identity validation versus domain validation. So domain validation already exists. You're looking more for identity validation, which, yep.
Hi, say your new SSL certificate authority is wildly successful and everyone on the internet is now using TLS and has your certificates. Seeing as the primary goal of TLS is to prevent man-in-the-middle attacks, say I go to your encryptionexample.com in my web browser right now. My web browser is going to make a connection on port 80 first. Now, if I'm a man-in-the-middle, I'll just respond to that connection and bypass TLS completely. How are you going to address
So
this?
the answer to that one is HSTS, right? And that, and of course, HSTS does two things. It deals with that, and it deals with the fact that people don't know that they need to set the secure flag on their cookies. And so huge numbers of websites set auth cookies, don't flag them as secure, and then they're totally cookie jackable. So you need ultimately for a secure site to have HSTS set. We will try to help sites do that, but it's in the category of things that can cause a lot of breakage, and so we need to have good tooling around turning it on for just a few minutes at first, and then gradually increasing the TTL and having good tests for breakage so that we can tell the admin to roll it back or which pages on their site are breaking because of it. So the plan is to definitely go in there and actually fix this stuff for people, but it's going to take work to smooth out all of those rough edges.
But I mean, even if every site is sending an HSTS header, the man in the middle is going to intercept the connection before the client receives that HSTS.
There are preload lists in the browsers, and so we could auto-submit. I mean, I think they probably haven't engineered for the sheer number of domains that would wind up on the preload list if we robo-submitted everyone that turns on HSTS with us. And so that's probably a bridge we'll have to cross with the browsers when we have enough deployment to cause a problem for them.
Do you think maybe a better solution would to convince the browser makers to start with a port 443 request and try HTTPS by default?
It doesn't help because the attacker can drop the packets and then wait for you to try 80.
That's a good point. Yeah. Thanks.
Will you eventually Will you eventually support wildcard certificates, or if not, is it okay to hit the API?
We will not support them at first, and then we'll look at how who knows what we'll do later. I mean, honestly, I could tell you why it's hard, right? Like, it's the people who are really mad about identity and phishing. If you give people wildcard certificates, they can go and get paypal.theirdomain.com or whatever, and they can do that without limits. And so we will get, unless we have a good answer to the phishing debate, wildcards will be politically sensitive for that reason.
So to follow up with that, is there any way at all that you could use this for .local domains?
.local domains and TLS don't entirely make sense. I think the thing one should aim for there is to try to actually get namespaces that are not colliding, or to make up new browser UI for .local. Maybe there should be an explicit tofu model for those local namespaces, but it needs to be engineered separately from public web naming.
All right, thanks.
All right, thank you everyone.
Very much.